algebra. Finish solving that now. Distribute 14x minus 70 equals 11x minus 22. Move stuff around and you get 3x equals 48. There is no specific way of what you move first. You can just whatever. And you'll end up with the same answer as long as you do the math correctly. So x equals 16. Okay? Again, here we have a fraction equal to a fraction, but I want you to just kind of think of common denominator, which would involve both of these. And it's really the same as cross multiplying. If you multiply this times this fraction, the 2x plus 5's cancel out, right? And you really just end up with 1 times 11x plus 8. If you multiply this fraction times that, the 11 plus 8 cancels out, and you just have x times 2x plus 5. And then you simplify that. You do a little bit of algebra. You got a quadratic equation here. This becomes, I'm going to write a lot more steps than you may need to, but just to show you so you can see it. You see you have an x squared there? Probably you're going to have to factor in some sort. So move everything over to one side. I always like to keep the x squared positive. Just for me it's easier than trying to factor with a negative leading coefficient. So I moved everything over this way, and it ended up like this. Okay, instead of jumping in and factoring right now, what should we do first? Divide by 2. And then it becomes easy to factor because a is 1 now. So I just do my empty binomials, x and x. Factors of negative 4 that add to negative 3. Negative 4 and 1. Then my solutions would be 4 and negative 1. Now, of course, you should take a moment to make sure they both work, because you might have an extraneous solution every once in a while. So check it. So if I plug in 4, I end up getting 1 over 13 equals 4 over 52. Is that the same? Yes. 4 over 52 is 1 out of 13. If I plug in negative 1, I end up getting 1/3 equals negative 1 over negative 3. Is that the same? Uh-huh. Negative over a negative is positive. Okay? So they're the same. So they both work. So they're both solutions. I just plugged them in, and that's what I ended up getting. Okay, turn it over. Oh, look what's up there again. Fill it in. If you don't remember, you just look at the other side, right? So what goes here? Minus equals a minus b times a squared plus a times b plus b squared. Okay? All right. We'll use it later. Don't worry, okay? It's coming. All right, so now, solve the equation. Check for extraneous solutions. So again, we have a fraction plus a fraction equals what could be a fraction, 3 over 1, correct? All you do here again is look for a common denominator. What would the common denominator be? 2x. So I'm going to think about multiplying everything inside there by 2x. If I multiply this first fraction by 2x, I really just end up with what? The 2's cancel, right? So I just have 7x. This over this times 2x, the 2's cancel, I have 7x. So kind of think about it in your head. 3 over x times 2x, the x's cancel and you end up with what?
6.
And this just has a 1 over it, so but 3 times 2x would be Oh, look at that. That's all you have to simplify now. Okay? So then you just have to solve for x. So minus 7x, 6 equals negative x equals negative 6. Check it, just to make sure it's not extraneous. When you do that, you get some fun fractions that look like this. Does that end up working? 7/2 plus negative 1/2, does that equal 6/2? Is that a true statement? Do you know where I came up with all those numbers? 6/2 has the same value as what? I know it's Monday, but what's 6 divided by 2? 3, right? So I just made this with the fraction of 2 denominator, all right? So it does work. All right, so this is really the same thing. What would be the common denominator here that we're working with? Both of these. And x. Common denominator. So then you go through each fraction individually. So this first fraction times that, the x plus 7s would cancel, and what do you have? 12x equals 1 times that stuff. So that's going to be part of it. Minus, what cancels here? The x's, so we have 12 times x plus 7. And then you make a purdy. And solve for x. Although you will have some factoring here. So this is going to be x squared plus 7x. I'm going to multiply this negative 12 through. And then you continue the process to solve a quadratic equation. You have to have it set equal to 0. So I'm going to combine some stuff and bring 12x over, and it ends up looking like this. So I combined stuff and I brought 12x over. Yes. Because, oh, this has an x next to it. I apologize. That's probably why you were confused. That becomes negative 5x, and then you subtract 12x and you get negative 17x. Okay, that's easy enough to factor. Factors of negative 84 that add to negative 17. Does anybody know? Negative 21 and 4. Negative 21 and 4. Think about it. 4 times 21 is negative 84, or 84. Yep. Negative 21 plus 4. X equals 21 and negative 4. Plugging those in, kind of some messy fractions. I can show you or not. I'll show you my work here. This is what happens when you plug it in, and they both do work. They both work, so we won't spend the time with that. It's just plugging in and converting fractions and checking to make sure they're true, and they are. So they both work. Or you could just whip it on your calculator, right? Okay, so this just takes it a little further, but it's the same idea. So what's the common denominator in all of these? X plus 1 and only once though, right? X plus 1 and 2x. And that goes back to what we were doing before. So again, you just go through each fraction. The first one we would just multiply 3x by 2x because the x plus 1's cancel. Don't write too big here, you'll run out of room. The second one, we multiply negative 5 times x plus 1. Then the outside, we just multiply x plus 1 times 3. Okay, when you do all this distributing, you end up with this. And then you end up with this. You can just write this down if you want. At this point, what should you do? Take out a 2. Yeah, it makes it a lot easier. Take out a 2. Now, A is still 1, right? I mean, A is not 1. So you use a box or whatever method you prefer. When you use a box, I'm not going to do the whole thing with you, but once you factor it, it would look like this. And then your answers would be, you set this factor equal to 0 and that factor equal to 0, and you get this and this. And they both work. I'm going to do this next one just in a shortened form because it's something you'll see. So notice again the denominator here is x minus 1, and wait a minute, this one can be factored, can it?
Yes.
What would it be?
X minus 1, x minus plus 1.
Correct. So what is our common denominator? It is. We only use one of these x minus 1s. So I'm going to multiply everything by that stuff. I'm going to show you what happens when you do all that. I'm just going to make it quicker. You end up with this eventually. You have to have it set equal to 0. So this actually turns out kind of nice. When you subtract, you get this. Just as a refresher, what do you do at this point? Take out an x, so it becomes really kind of easy. All you can do is take out an x, and it looks like this. And then you set each factor equal to 0. So your answers would be x equals 0, and x, this would be positive 7/5. The last one's quick, but I want you to see something on the last one. Okay, what's the common denominator? X minus 2. So we're going to multiply everything by x minus 2. What does this fraction become right here? Should be pretty quick right now at this. What's this fraction become? Just 5x. This is 7 times x minus 2 plus 10. When you simplify all that, you get this. When you simplify all that, you get this, and x equals 2. Do we have a problem, Houston? What is it? What happens if I put 2 here? Ah, nini nani no no. Okay. Uh-oh. It's extraneous. Doesn't work. So always check. But I can't let you get away without seeing the cube of a binomial difference. So we're going to factor this. This is the same as a cubed minus b cubed. Why do I know that? What do I know about 27? It's a perfect cube. I know 27 is a perfect cube. So I'm going to write it like this. X cubed minus 3 cubed. The reason I do that is because my a will be x and my b will be what? 3. And now I can use that pattern. So if I have to factor that, what's the first binomial going to be? X minus 3. And then I have a trinomial, which will be what? How do you feel about that?
Good.
Good, okay. That is it.